For more videos, visit forthesakeofeducation.com. Alright guys, let's do this problem that says find the Thevenin equivalent for the circuit containing dependent sources shown. So, the first thing that you gotta take into account is that since the current going through this cable right here is ground to ground, is not doing anything. So Ix is equal to 0. This is an important point to take into account. Now, you know that Ohm's law is V equals the voltage equals the current times the resistance. So, the Thevenin equivalent, as measured from A to B, of course, so it's equal to VAB, is equal to the current times the resistance according to Ohm's law, which is equal to the 25 ohms, this 25 ohms right here, and the current going through it. The current being negative 20 I, because if the current is going down this way, then it will be going up this way, so it's negative 20 I. And this is equal to 500 I, and that is the Thevenin. Now the current I is equal to 5 minus 3 V, this 5 volts minus this 3 volts, because the current is this current right here, divided by 2K. And again, this is Ohm's law. As you can see, if V is equal to I times R, then I is equal to V over R. The voltage measured from here to here is this voltage, and the resistance is the resistance. The voltage is given by 5 volts minus 3V. So you know that this V right here is this V right here, which is the same as the Thevenin. So I is equal to 5 minus 3 times the Thevenin over 2K. So when you solve for the I is also equal to, according to Ohm's law, V over R. So the I is also equal to Thevenin over minus 500 is equal to 5 minus 3 Thevenin all over 2000. I just replaced the 2K by the 2000. Now this Thevenin minus 500I came from right here. This is actually minus 500. Don't forget this minus right here. So you know that this equation tells you that Thevenin is equal to minus 500I. Therefore, I is equal to Thevenin over minus 500, and that's what I replaced this I right here with, Thevenin minus 500, in case you're wondering. So now, as you can see, we have one equation and we got one variable. You can basically solve for the Thevenin. This becomes Thevenin is equal to 5 minus 3 Thevenin over negative 4. Now this is basic algebra, guys. Negative 4 Thevenin is equal to 5 minus 3 Thevenin, and this becomes Thevenin is equal to minus 5 volts. The minus means that the polarity is reversed. Now, let me turn the page. That being said, we got to do this will be the short circuit current, and we have to short this dependent source right here so that the source becomes 0. And now we're gonna find the short circuit current to be able to find the Thevenin resistance. So I is equal to what? You just gotta see what this current is. Of course, this I is gonna be 5 volts because you got the source right here over 2K according to Ohm's law. So this is going to be equal to 2.5 milliamps. This is this current going right here. Therefore, the short circuit current is going to be equal to negative 50 milliamps, because 20I is going down, it's going this way, and it's going to go opposite to the short circuit current, so it's going to be negative 50 milliamps. And our Thevenin is simply B Thevenin over the short circuit current, which is found, so it's minus 5 volts over minus 50 milliamps. Sorry about that, I got a phone call. Okay, so it's minus 5 volts divided by minus 50 milliamps. So as you can see, these signs are going to cancel out, and the resistance is going to be obviously positive at 100 ohms. So the equivalent circuit is going to look something like this. 100 ohms, and this is going to be 5 volts. It's positive 5 volts because, as you can see, I switched the polarity. I put the negative at the top and the positive at the bottom, and this would be A and this would be B. So when you're doing dependent sources, you just gotta get creative. You just gotta remember this current is 0. As soon as you remember that this current is 0, then you understand that you have two separate circuits where you can build equations and you can relate them because the dependent source relates the two circuits. So, final answer. Please comment below if you want me to do any problems, and I'll be happy to help. Thank you.